6 participants, 9. Okay. So I hope that you have given the attendance in the previous session. If not, you can give it. Okay, you can enter your attendance. Okay, so we were discussing that generally the vehicle is steered by changing the direction of front wheels. Okay, and the rear wheels will follow the front wheel. Okay, so for example, suppose it is the vehicle like this. It is the chassis of the vehicle. That rigid skeleton is called as chassis, which is just above the wheels. Okay, is called as chassis. So here, uh, the part on which the wheel is mounted is called as axle. So this part is axle on which you mount the wheel. Okay, axle. So here is one wheel. Here you will have the another wheel like this. So these are say these two are the front wheels. 1 and 2 are the front wheels, and back wheels are mounted on back axle like this. So generally what happens, the back axles are fixed with respect to the direction of chassis. So chassis के साथ ही back axle is fixed like this axle यहाँ से यहाँ तक, it will always remain perpendicular to this line, means this axle is fixed. Okay, now what happens in case of the front wheels, the axles at front, okay, they can be changed in direction. Okay, so suppose for example it is possible to change the direction of this axle like this. So your wheel will come to this position as you will turn a left, if you will turn in left direction, and this will as it will be turning towards the left, so its next position will be like this. Are you getting? The front axles can be turned, okay, about this pivot point. This point, say this point is point A and this point is point B. So this point A and B, where there is pin connection, okay, these axles can turn about this point. Okay, so in order to turn these axles so that you can turn whole vehicle, entire vehicle, there are some steering mechanisms which we will learn today. Okay, and we will also see uh, what is the fundamental condition of correct steering. Okay, so let us see that. Okay, so it is shown to you the vehicle chassis like this. So it is your inner front wheel, inner and outer front wheel. How you will decide? See, it is the inner front wheel and outer front wheel for a left turn. Suppose this vehicle is going in left direction, so driver has to turn it. So depending on this direction, if you are taking a left turn, left front wheel will be your inner front wheel, and the right front wheel will be your outer front wheel. Okay. So I have already told it is back axle, and back axles are fixed. They do not turn about the pivot points. This is fixed as with respect to chassis. Okay. Now suppose if you are taking left turn, and because of that, using some mechanism, if you have changed the direction of front wheels, so if you are taking the left turn, you will find that the angle of turning of inner front wheel theta is greater than angle of turning of the outer front wheel, that is phi. Okay. Now it is desired that all the wheels, okay, front wheels as well as back wheels, should turn about the same ICR point. Okay, in order to avoid the skidding of the vehicle or slipping of the wheels sideways. Okay, so generally what happens, if you might have also observed while drawing, when you will try to turn the vehicle, so if vehicle is very old, so it might slip the wheels. Instead of turning, instead of rolling, they start slipping on the road surface. Okay, so why that happen? That happen because of this point, ICR. If ICR is not matching of all the wheels, all, then the your vehicle might slip instead of rolling. Are you getting what I am trying to say? That when you yes, when you turn a vehicle, at that time the motion of the wheels should be a rolling motion, not the sleeping one. Okay, if tires will slip, definitely there will be more wear and tear. That will reduce the life of the tires, life of the wheels. Okay, so it is the condition that all four wheels should have the same ICR. Now you know that back wheels direction is already fixed. Okay, so ICR must be, it is the direction of back wheels, the velocity of back wheels. So its ICR will be perpendicular to that in this direction. Okay, so here the gearing mechanism is so designed that ICRs are tried to be at the same point. Okay, and obviously the inner front wheel will rotate more, will turn more as compared to the outer front wheel. Okay, in order to satisfy this condition that its line should pass through the ICR. Okay, now uh, let us see some terms like what is A called, what is B, and what is C. So A, just a second. Okay, yes. So A is what? A is the distance between the front wheels. Distance between the front wheels measured at the centers of wheels like this. So it is called as wheel track A. Okay. Next term is wheelbase. So what is wheelbase? That is the distance B. You can define it like the distance between front axle and back axle. Okay, or in terms of wheels, how you will decide it? It is the center to center distance, center to center distance between front wheel and back wheel. This is called as wheelbase. So if sometimes if you have read the car manual, so All these terms are given there. What is the wheelbase of the car? That decide the length of the car. Okay. And what is c? C is the distance between the c is the distance between the pivots points where these axles are pivoted here. So c is the distance between pivots A and B. This distance. Okay, you remember this. You remember what is theta, what is angle phi. Okay, and why the ICR should be same. If ICR is same, the vehicle will literally roll and not slip. Okay, so here now see the triangle IBP. IBP, this triangle. So in this triangle, if we see the geometrical relation, that is cot theta. So cot theta you can write as BP upon IP. It is cot theta. Okay. Similarly, you consider the triangle IAP. So I is here, AP, this triangle. So this angle phi, you can write cot phi. Cot phi is equal to AP upon IP. That is your cot phi. This way. Getting it? AP upon IP. Now this AP, this distance is the sum of AB plus BP. So AP is equal to AB plus BP upon IP. Okay. Again, you separate these two terms, AB upon IP plus BP upon IP. So what is this? AB upon IP? AB. AB is equal to what distance? Distance between pivots A and B is C. Okay. And what is IP? So IP, you can see this distance is nothing but equal to B. This IP is equal to B. So that you can put AB upon IP is nothing but C upon B. C is the distance between pivots here. Okay, and what is BP upon IP? So BP upon IP you can see here in cot theta. Cot theta is BP upon IP. So I can write this equation as cot phi is equal to C upon B plus cot theta. And finally I will get an equation. So cot phi minus cot theta, this should be equal to C upon B. Okay, this particular equation is called as the fundamental equation of correct steering. Okay, if you want to have the correct steering, then what should happen? That this relation between angle phi and angle theta should be satisfied. What are angles phi and theta? Phi is the angle of turning of the outer front wheel, and theta is the angle of turning of the inner front wheel. Okay, so if suppose if during any turning angles, sometimes you have to take very sharp turns, right? And sometimes your turn is not that sharp. So depending on sharpness of the turn, your turning angle will change. Okay. So whatever mechanism you use for steering, in all the turning angles, this condition should be satisfied. Okay, that is, it should be equal to C upon B. If at all turning angles this condition is satisfied, then your mechanism is fundamentally correct for steering. If suppose this difference does at any turning angle, if this difference is not equal to this c upon b, then what will happen? That vehicle will skid, will slip in turning. Okay, so it depends on the that how much is your turning angle. Okay, and based on that, skidding will take place. Skidding of the wheel will takes place. Got it? So there are some mechanisms which exactly satisfy this condition, that during all turning angles this equation is satisfied. But there is some mechanism which uh, does not satisfy this equation in all the turning angles. Okay, so we will discuss that when we will be dealing the different steering mechanism. So generally the steering mechanism, different steering mechanism is a Davis steering mechanism and Ackermann steering mechanism. So what are the advantages, disadvantages and working of those mechanism, we will see in the next class. Okay, are you
Okay, sir.
understanding it?
Yes.
Okay, so if any point you need more clarification of, you can always ask, you can raise the point even in the lecture itself. So we'll stop here, and we will continue next time. If I have to take the lecture tomorrow, I will inform it. Okay, otherwise there will not be any lecture. I will decide till tonight. Okay, yes or no?
Yes, sir.
Okay, so let us stop here. I will end the meeting now. I hope you have given the attendance in chat box.